Welcome everyone. It is a pleasure to see all these people joining together for different parts of the world and in this very exciting field of CPV, which well, it started a few years back, but it seems that in the last couple of years it has experienced an enormous growth from the industry side, and its experience also is capture a lot of attention from renewable industry in general. I will be together here with Francisca Rubio, which is our R&D director, and I will be giving an overview on our activities here, and hopefully give you also a broad overview of what the status of CPV these days. A bit of an outline of what my talk will be today. I will give you, as I said, first a background on our activities, some basic about CPV market and how CPV plays in the general renewable and PV market, at least in Spain, and then I'll go directly in discussing about our infrastructures for our plan of this newly created institute, an R&D plan that is being developed on those infrastructures, our activities, and certainly the large opportunities and a lot of challenges still to be met by this technology. Well, starting from what we are, where we come from, the ISFOC is the Institute of Concentration Photovoltaic Systems, and we started back in September 2006, so it's been 2 years in the field. The institute started as an initiative from the regional government in Castilla-La Mancha in central Spain, and they sought the commission, the Institute of Solar Energy of the Universidad Politécnica de Madrid, to develop an R&D plan that could be implemented in the region and could go much farther than just installing power. They wanted to see how the development of the industry and how the knowledge could be created in this region, taking advantage of this exciting field and the opportunities that are given here in the region. So finally, the financing of the project was covered by the National Ministry of Education, and ISFOC was incorporated as a company, as part of the group of companies from Instituto de Finanzas, which is the company of the local regional government who manages all investments in the region. So our main goal, which is already becoming or being met, is to become a center of reference, providing information about the power and productivity of commercial CPV systems through the installation and connection to the grid of a number of CPV power plants of the technologies that were ready to become available in the market. So our project currently is aiming at installing a total power of 3 megawatts. We'll talk about those installations later. And using these installations, the first pilot CPV power plants from companies already in the market, and use these installations as our test bed, as our laboratories in the field to prove and demonstrate the productivity, as I said, and the power reliability of this technology. As a second goal, as we are depending on the Ministry of Education from both national and regional government, is to use these facilities for training both at academic level and at the industrial level. So we are aiming at attracting the attention for a number of academic institutions and bringing researchers to our facilities and use our facilities to further develop this area, and also with the companies and institutes that are partnering with us to use these facilities as a training field for their staff, as the growth of the industry has been so large, the renewable and PV industry in general has been so large in the last few years. It is very difficult for the sector to fulfill all the requirements in terms of manpower, especially, and trained manpower is one of the main difficulties that this sector is facing. So we want to play our little part in there, and using all our resources to get people trained on actual installations and very high-tech and up to date on the latest development on the technology. So again, we are based in Castilla-La Mancha, which is the central region of Spain. You'll see here in blue all this area. Our headquarters are based in Puertollano, halfway between Madrid and Sevilla. It is a nice area, and well, we have an average global irradiation close to 1900 kilowatt hours per square meter, and we can see that it is the region in Spain which is experiencing the largest growth in terms of PV installations, having installed already. It's our numbers from July this year. We have there are PV installations up to 244 megawatts installed in the region, out of the 926 megawatts total installed in Spain. So it places in the first position in terms of power installed in Spain. As most people know, this is increasing largely in the last few months, and we expect a large growth in the last few months of the year, due to the specifics that I won't discuss much about the new regulations in Spain about the PV feed-in tariff subsidies. Just a bit on concentration photovoltaics, although most of the people joining us here today might already know about. I just want to mention some of the critical part of items in this technology that we should be pointing our attention to. So in general, concentration photovoltaics is a technology in which the active part of the module or the sensor is reduced in area, and a set of optical design and materials concepts are used to focus these the light onto this small solar cell. The optics, these three areas, I mean the optics, the high efficiency solar cells that are used, and especially the solar tracking, which is needed, is compulsory in this technology to track the sun and detect and use this direct normal irradiation to generate electricity. These are the three key parts in the technology, and the three key parts where most of the developments are taking part at the moment. So optics with a set of different options that I'll discuss later. High efficiency solar cells based mainly on 3-5 compound semiconductor compounds, 3-5 multijunction solar cells, and solar tracking, which with many different concepts are becoming readily available in the market, not only for concentration but also for flat photovoltaics. Here is a few of the issues around concentration photovoltaics, which have made this technology ready to become available in the market, which is giving the initial results needed to prove that this technology is going to play a major role in the future deployment of renewable energy. And basically, as I say, there's three elements in here that I've mentioned already, which are the high efficiency cells, the needs for tracking index technology, and the optical elements. Some other issues or aspects of this technology, well, we have the the current and the voltage behavior at high concentration, which normally it is proportional to the concentration ratio. For high concentration, we are talking to concentrations up to 1,000 over 1,000 suns, which is basically a geometric concentration. The amount of energy impinging on the solar module surface is then concentrated by that ratio over the high efficiency solar cell, and which produces a current proportional to this concentration ratio. Some other aspects in here that we should take into account about the future of this technology is the energy payback. There's still a lot of research to be done on this, but apparently this is going to be one of the major advantages on this technology, and in terms of the general public to understand one of the benefits of this technology could be a good metric to take into account is the energy needed for the time needed for the system to produce the energy that was used to manufacture it. Currently for silicon we are talking about more than 2 years, and for all the estimations for CPV will depend on exactly on the type of technology that we are talking about, but about CPV in general we can be looking at a year or less than a year that could be achieved for this metric of energy payback. Another clear advantage for CPV will be in terms of recycling, as we will see the construction and materials used for this technology are materials and technologies that the traditional industry know how to handle after the life of the system. We know how to recycle plastics and aluminiums and other metals in a very optimum way, which makes this technology, this type of technology is a clear advantage over flat PV in this sense. Whereas in flat PV, when you have all these laminated modules with silicon already with soldering and metallization, which makes it very difficult or very expensive to recycle. Whereas for concentration photovoltaics, the components, the active components or the electronic components of the system could be easily dismounted and recycled on one side, and then the rest of the module could be easily recycled by, as I said, traditional technology. Another issue or aspect of this technology is the industrial sectors that are being involved, and is attracting industrial areas from technologies or industries that have not been traditionally involved in photovoltaics. You have companies coming from a background on optics, on automotive industry, white goods like refrigerators and washing machines, that they know how to assemble precisely components, electronic components, and plastic and glass in a very precise way. And we can use all this knowledge generated through a number of years in high volume manufacturing to be implemented in this technology as well. As I say, for the optical elements as well, this is a sector on optical design that has experienced also an enormous growth in the last few years, mainly from automotive industry. If we look at the headlights of the cars in the last couple of years or 3 years, there's a great difference of what they were before. Looking at design and materials for non-imaging optics, in which we want to concentrate the energy on a surface onto a surface of a solar cell without the need of forming an image, but just concentrating the amount of that total energy in that surface in a most optimum way over the surface of the cell. All the design concepts and material that have been used in a similar problem for the headlights in automotive industry can be directly applied to concentration photovoltaics. So we can take again advantage of a high volume sector, take advantage of this growth and this knowledge and bring it to this emerging sector as well. Again, one last thing about the efficiency and temperature reasonable values. We see that from is one of the major concerns in PV, and one of the causes of efficiency loss in the field. Having a large having the efficiency decrease with higher temperatures. In the case of high efficiency cells, on these 3 junction cells, they are ready to be working at higher temperatures with a minimum loss of efficiency, which make this technology more attractive to this very sunny region and with large irradiation levels. I'll discuss some of these issues in particular through a number of slides here. Now, talking about the 3 junction cells, we see here a graph that most people have seen many times. This is a graph showing all the results on best at research level cell efficiencies published by the NREL in the US. We see the numbers from early 70s until today, and these are the record for the efficiencies at different technologies. Doing a comparison with some of the technologies, traditional technologies, we can call them traditional now on PV. We're talking about silicon-based or thin film technologies. In the graph we can see them in blue and green, in which over the years have been increasing their efficiencies until we get in the last few years they seem to reach a plateau, and actually getting improvement on this efficiency is getting, seems to be a high technology cost. Something has to happen to get a really large change on these efficiencies for them to get to the numbers that are needed now for deployment of PV. Still, this is based on the technologies that are being deployed at the moment. We can see, for example, for crystalline silicon values up to 24 or 20, between 20 and 25%, whereas the commercial silicon cells are already available at around 18%. If we look then at multi-junction cells for concentrations based on 2 or 3 junctions, we are talking about this part of the curve starting in late 90s. Just looking at the way this curve is growing tell us on how these technologies are, the people are paying attention to these technologies and how interested it is to deploy them in the field. We can see the best 3-junction cell from 2007 at 40.7% efficiency, whereas commercial 3-junction cell can be already available around 38%. Looking at the roadmaps for the different manufacturers of 3-junction cells, we expect to have efficiencies close to 50% in between 5 to 7 years time. Just a remark about the 3-junction cells, why the high efficiency, mainly the high efficiency becomes, we have this, the setup of these high efficiency cells is based on having 3 cells together, built together onto the same substrate, and they are connected in series, in which each one of the cells is sensitive to a part of the spectrum. And this way, having these 3 cells with less efficiency each, but together they set up large efficiency, at least they are taking advantage of most of the part of the solar spectrum. We can see the normally it is based on a germanium substrate, a cell based on germanium which is sensitive on the red part of the spectrum. and going to the blue to different 3,5 alloys like gallium indium arsenide for the middle cell and gallium indium phosphide on the top cell. There's a lot of research being done at the moment on materials for these multi-junction cells, looking at having more cells onto the same device, and adjusting also matching currents, as you might imagine. Matching currents on various cells connected in series is also a critical issue in this field. Talking about the optics, there are a lot of different options. There are a lot of different designs and materials. I just picture here a few of the basics of different approaches that are being deployed currently. We have from the single Fresnel lens, a single optical phase, Fresnel lens plus a secondary optics that helps improving the acceptance angle of the system. Novel designs like total internal reflection that helps reducing the focal length, and also reflective designs with mirrors and lenses, having either a single phase or two phases, placing cells within the modules or on the surface. Some of the concentration technologies that we can see so far, there are some historic systems installed, like from the early 90s, this Euclides project in Tenerife, with this parabolic trough and on silicon cells, which I believe it's still working, and there has been lots of lessons learned in this field. We have approaches like the one from Solar Systems in Australia, which is a large parabolic mirror with a group of 3 junction cells in the focus of the parabola. We have Fresnel lenses type of devices on a 2-axis tracker. This is actually one of the first trackers that was installed in our facilities in Puertollano. And mirrors like the one from Solfocus from the US, which is using small parabolic mirrors on modules, set up a number of parabolic mirrors in a single module. So as you see, there's a variety of technologies, and each one have the approaches. Each one is aiming at achieving large efficiencies, and relative to cost and reliability, each technology follows their own path, but all of them will probably come up with really innovative developments that could be applied or being already applied in the field. In terms of concentration photovoltaics, I will go one step further about talking how the market is around concentration photovoltaics. This is a graph from ENCOR that probably you've seen already around in some other presentations, just looking at the field of application for CPV, and looking at the future, that this type of technology is looking at a range of large commercial and utility size installations, getting some area in together with large CSP thermal installations, and having also some area in common with large deployments on silicon or thin film technologies. But let's say that an optimum, we believe that an optimum size for CPVs, these large utility installations, in areas where there is large numbers of sun hours and high irradiation and large direct normal irradiation. Looking at the photovoltaic market in general, I have numbers here from 2007 systems or power installed in 2007, in which Spain already became in second place after Germany. in general, we see that global growth of the industry experienced during 2007 at 62%, whereas in Spain the number of installations grew dramatically, and we experienced this 480% growth. We will see how this market will remain in a month or less than a month when the new regulation becomes in place in Spain, but I do hope that things will become easier for all the companies being in this field, in Spain at least. Looking at the numbers on Europe, installations in Europe across from 2004 up to 2007. You see how Germany has been leading the way through all this year, having another close to 1 gigawatt installed yearly. Spain experienced its main growth in 2007 with good conditions of the regulation and feed-in tariffs, and from 2007 we will see other Southern Europe countries becoming playing a major role in this market, like Italy, Portugal, France, and Greece are already implementing these subsidies, and we'll see their growth probably in the next few years. This is just a slight comment about the regulation. I want to comment much about that, as this is we will see what will happen in a couple of weeks. This is the situation how the subsidies were in Spain up until the 20th of September of this month, in which we can have an average close to 42 euro cents per kilowatt hour subsidy for installations of ground, and the drafted new regulation is aiming at reducing these subsidies more than 30%, and also introducing some kind of cap in the total power that could be installed yearly. There is still a lot of discussions, and the different associations of the industry in Spain, they are lobbying. Different departments of the administration are looking into the draft, and we will see what will happen in the next couple of weeks. I wouldn't, after all the changes that have been happening about different drafts along this year, I wouldn't like to make an opinion at this moment, because anything could happen, and the market might be boosted in some way by the new changes on this regulation, or it might be slowed down, as unfortunately it seems that is going to happen. But anyway, at CPV is related, we are already in having a very small part in this market, but we have to prove that this technology is reliable, that the cost can be reduced, and the efficiency and productivity could be at competitive terms with other PV and other renewables. So still believe that in the short term, with a short track record of the capabilities of the CPV industry, we can be there, and we can make at least people know that this technology exists and can experience a large growth in the short term. One of the issues about the cost of electricity, levelized costs of electricity for CPV, these are the values presented in the latest EU PV conference in Valencia a couple of weeks ago by Solfocus. I believe it's a good example of what are the short-term goals for one of the major players in CPV, which might not differ too much on the objectives of the roadmaps for other players on this field, which are already having plans for increasing capacity of manufacturing and increasing number of installations globally. We can see here the levelized cost of electricity across time frame up to Q2 in 2011. as compared to average price of standard fixed silicon PV systems. As setting the we see they are based also on the price set price for systems, and how this price per power can be reduced according to the expected increase in capacity for production, and how the levelized cost of electricity is being reduced and becoming competitive with other technologies. Talking a little bit about the cost per watt of systems installed, due mainly that the market is mainly driven by these subsidies, either for Spanish or government. So we can see a large change of on average selling prices of modules. As we see currently in Spain, before this new regulation, we were running at about 6.3 euros per watt on installed systems for flat PV, which places somewhere close to here on these large numbers. The change in the regulation and the expected reduction on the subsidies and feed-in tariff might force these prices to go down and levelize to the prices that being seen in some other geographical areas, where the average selling price of systems could be much lower, even 20%, down to 4.3 euros per watt. So looking at the roadmap and the estimations for this type of technology, it seems aggressive, but I'm sure that once we reach 2010, for example, and we look back, it probably will not look as aggressive as they look today. The market is given, there's enough room in the market for everyone, and the expected first results that are being produced for CPV are giving confidence to most of the manufacturers to meet this hard future, or these hard roadmaps. Basically, looking at capacity for manufacturing, that's where most of the manufacturers have to carefully look at and make sure that the capacity matches all the future needs and demands from this field. That was about cost. There's another main issue, that is reliability. Those two things will certainly help and determine how this technology will become available, or will play a major part in the renewable sector. From our work at ISFOC, we can play a major part here in reliability and testing of systems, and proving the efficiency of the system. Let's say the cost is mostly a matter of work from each company and being able to meet their goals. But in this sense, we're already working, we have been collaborating in the development of the standard, the 62118, which is the first IEC standard in terms of reliability for CPV modules, which was passed last December, and now it's being implemented in a number of laboratories around the world, and all the companies are working hard to meet the requirements of this standard, and start producing quality and reliable systems. The work from the IEC committee and other reliability groups are focusing on these other areas, as the performance and rating of modules, safety of these installations, the tracking systems, which need standards for trackers specifically applied for CPV and PV. We at ISFOC, we are leading the group, the working group within the IEC committee for indoor and outdoor measurements and performance the performance and rating of the CPV modules. And also another line will be to look at future amendments for the 62108 standard just passed. We are experiencing or collaborating with all our partners in following up all how these tests are being performed and identifying weaknesses on this standard and looking at ways to improve and matching the test conditions to what the system will actually need to prove in the field. So as a summary in this part, I will say that the technology for CPV is already there, has been proven. We have a number of industries already emerging, and there's more and more players becoming playing now in this field, coming with new concepts and new technologies and new approaches to this technology for a market that still needs to experience a large growth. I would say, like for example, in Spain, with all installations up to more than 1 gigawatt already installed, we are not covering more than 0.4% of the energy demand in Spain. So that means that there's a lot of sun, and there's a lot of need for this technology to grow and room to grow. So the technology is there. We have to prove that the systems have the quality and they are reliable enough. The industry have to prove that there's a roadmap that is being met in terms of cost reduction, and this is the opportunity to reach the market. The other players in renewable energy markets is not a traditional industry set in there. All of them are getting new developments into their own fields. So it's a very dynamic sector. We do believe that CPV has a lot to prove, and there are a lot of challenges, but the capabilities of the technology and the current players in the market is very good, and to be able to meet these requirements and face that opportunity that is being given. So this in general as a review of what CPV technology is and how is the market surrounding this technology. Now I will discuss tell you a little bit about the infrastructures and our own project, what are our plans and how far we are into our plans. Our initial plans was to have different installation about these 3 megawatts, as I mentioned, having them deployed in the different areas along the central Spain in the region of Castilla-La Mancha. Due to different issues as grid connection and availability of land and environmental issues, at the end, in this first phase of the 3 megawatts, we are placing the installation in these 3 different sites in Talavera and Guadalajara, having Madrid somewhere here in the middle, and south in Puertollano, where we had our headquarters plus a couple of sites. We will have in the future, for new projects coming, we'll probably have them placed in these eastern areas of the region. This initial infrastructure, as I say, the 800 megawatts, there's been a couple of international calls for tenders launched, in which we carefully evaluated the technology together with the help of our advisory scientific committee, and we selected these technologies as being the ones with a product most likely to meet at least our demand in terms of timing of the project, and also that they were providing very innovative technology and that could be deployed successfully in the field. A first call for tender, an initial phase which is almost ready to be connected to the grid. I hope that within the next 3 to 5 days we can have most of this initial phase already connected to the grid. We have in this first phase, as I say, 500 kilowatts from Concentric Solar in Germany, 500 kilowatts from Sol Focus from the US, and 700 kilowatts from Isofoton in Spain. A second phase, that was another call for tenders that was launched at the end of last year, and will start works for installation within 2-3 weeks. Are 300 kilowatts from MCOR in the US. I'm sorry, there's a picture missed there. We have 300 kilowatts more from Concentración Solar La Mancha Renovalia Energy from Spain. Arima Eco from Taiwan will install 300 kilowatts, and Sol3G from Spain will start 400 kilowatts more. We hope that this 1.3 megawatts could be connected to the grid up and running in the first quarter of 2009. We were aiming at having them connected to the grid in January, but we are waiting to see how the new regulation goes, and the administration work might change our timing a little bit, but it won't go probably much further than the first quarter of 2009. We are also setting up the infrastructure for our headquarters here in Puertollano, in which we will have a 3,000 square meter building that will include laboratories, office space, and maintenance area. And we expect that to have it ready by next summer next year, although part of the building will be available at the end of the year, mainly labs and maintenance area, so we can start already work on a number of projects on the installations that we have, and a number of national and international projects which we are we've started recently. One of our main works as well is to set up a solar resource map of Castilla-La Mancha. We all know how difficult it is to get reliable data on direct solar irradiation. So our plan is to have, with each installation, and which covering a large area on the region, set up a number of weather station in which we will monitor all data, not only meteorological data, but also everything related to radiation, global, diffuse, and DNI, getting accurate values for that, and having a quality test on that data to make it available for the industry to evaluate their productivity, correlated with reliable irradiation data, which currently is difficult to obtain, and it's more difficult to obtain with reliable numbers. This is a picture of our current site in Puertollano. As I say, everything is finished and ready to connect to the grid. Hopefully in 5 days we'll be producing the first kilowatt hours. The building is on the north side of the site. Here we see 3 of the technologies. This is concentrics. At the back we have Sol Focus, and on the right we have Isofoton modules. This is a field of 800 kilowatts, and the rest of installations will be placed in different sites, as I say, either in Puertollano or other sites in the region. I just wanted to show here some of the first values on what we've been doing so far, is rating the power on this technology, on these arrays. And so far, with a procedure that we are proposing as an international standard, it's giving us also results, and way of improving this procedure is as the rating in the field of the power of these modules. This is the normalized power for a number of trackers for the different technologies, in which we see deviations that won't go much than 5% on initial measurements that normally for each array has been done on a single day, a number up to 15 measurements on sunny days on irradiation about 700, I believe it was. For all the installations that we are going to place here in our project, numbers on the estimated production runs between 1800 to 1950 kilowatt hour per kilowatt installed. We need to this is based just on simulations and estimated data from radiation of the site. As I say, we're going to connect to the grid soon, and I do hope and truly believe that we will be within those numbers in very soon, and with actual numbers that we can start publishing very shortly. Now, our R&D plan is based on using all this infrastructure to produce results that we can give out to the scientific and technical and industrial community. We have a different number of R&D lines in which we are working. We have a number of lines which are already being defined together with our partners in the project, mainly about improvement on concentrators and the technology for each of our partners, working on maintenance and recycling tasks to be developed on this technology. I mentioned already the work that we are performing on standard development and also developing together with the University Politécnica de Madrid measurement tools and procedures for this technology. Solar radiation, I mentioned already our project for the solar map resource of Castilla-La Mancha, where we are heavily involved as well. And there is a number of activities around environmental issues, training and consultancy, and dissemination of the technology, which we are trying, like with this presentation today, is to give in as much as possible, to be in as many venues as possible talking about this technology and trying to push together with all the players in this sector to show and make the world know that this technology exists and what the capabilities of these technologies are. The activities that we are performing within these R&D lines and collaboration with other partners are mainly engineering and maintenance support. We are performing measurements about rating and productivity on CPV power plants and reporting on these previous activities. We work, as I say, in the development standard together with the IC committees. We will be reporting on DNI data that we'll be collecting from the different weather stations that we'll be placing in Castilla-La Mancha. We are already involved and will be involved in more R&D projects, both at national and international level. We are defining already training activities together with our academic partners, or at the local level as well. We are doing already a number of activities for schools and local universities, as well as I say about dissemination. We are implementing as well quality control, quality systems in our activities to also help our partners to develop their own quality assurance system. The legal support that we provide, we have with the continuous change on regulation, there is a need of almost, I won't say daily, but weekly, mostly you might need to pay attention on new regulations and changes on the regulations and different regulations for regions, provinces in Spain and in the rest of Europe. So that makes difficult to get clear things about all the legal things surrounding this field. We are learning about that, and also will be able to support legally some of our partners as well in this sense. So at the end, we would like to develop a CPV business model in which we consider not only the economics aspect of it, but also all the technology and development issues that are needed for this business to be successful in the future. Just as one of my last slides, I want to mention some of the challenges that this technology is facing and has been facing for the last years. From the prototyping, development of tests and standard is clear that to produce a product, you need to have proof track record on all the tests, and the need of standards to prove that these products that the companies are developing will be successfully deployed in the market, both at the prototyping phase and the manufacturing. Now that most of the our partners are already having commercial systems deployed, they know about how hard it is to meet standards when the standards are not there or are being developed even at a lower pace than the industry is developing. So it is a task for everyone to help the industry growth and help the standard growth at least at the same pace as the industry is growing. The rating for power and energy is needed. There's a large discussion already around within the CPV community about the conditions, what we define as standard conditions, and to get an agreement on these standard conditions and to get metrics that are comparable with PV and of course with the rest of renewable energy technologies. Reliability. It is clear that through some of these standards we can prove the reliability of these systems, but it won't be until we have the system working in the field for a number of years that the reliability issues might arise, and we all will have to look at the specifics for reliability on CPV. Materials availability, it's also a concern, as we've experienced recently for flat PV, the lack of silicon and the problems in the economies of scale for availability of silicon. We have to look very careful on all the materials needed, especially for the development of the high efficiency solar cells. That all the materials that will be needed in the future according to the manufacturing volume that are already there, and that they could be supplied at the rate that the industry will be needing them. The cell efficiency, we know that there are a small number of companies developing cells at the moment, but there's a large number of companies already looking into having high efficiency cells for CPV. So we'll probably see in the next 2-3 years more companies coming out and an improvement of this efficiency and improvement on the availability on these cells to be able to supply them to the industry. Tracking systems, I mentioned all the issues already. There are a number of different options about tracking systems needs to be solved, and this tracking system is a key system for CPV. The need for accuracy at the moment being below 0.5 of a degree for of accuracy of sun tracking, that is not easy to be met by any manufacturer which is looking probably at trackers for flat PV. The requirements are more strict for CPV, but the companies are already working on that, and there are already a number of tracking systems working for CPV. It's one of the fields within the CPV that will probably experience also a large growth in the short term. And lastly, I have the regulatory and grid connection issues. At least in Spain, we are learning a lot on the difficulties that are there for getting systems legalized and connecting to the grid, and all the legalized installation to get access to all the different feed-in tariffs. all these regulations are new for most of the countries, and both the administration and the users will have to learn and make it simple. I would put an example for it is getting better in Spain, but at least a couple of years back, or less than that, a year back, you might see installations that you could be deployed, like for 1 megawatt installation, even for flat PV, that it could take real work, 2 months or 3 months the most, for getting it up. You might spend a year or a year and a half in getting all the paperwork and all the regulatory issues solved to get that installation legalized. Well, I hope that as the volume gets larger, the administrative issues becomes smaller. So as a conclusion, I would say that giving you an overview of how the market looks, the technology is ready there, and our positioning here is to work together with academia and industry to help bring the best technology with quality and low cost into this market. It is our goal, and I hope that we can make it. At the moment we are finding very good partners, and we hope really that we can find very good partners for our future projects as well. I think I've gone a bit too far from the time that I had. I want to thank you everyone that has been hearing me at this difficult time of the day.
Thank you, Pedro,
And,
for your
well,